financial services company. I've been exploring Python for the last few years, so I keep learning something new every day. If I really go back and try something else, don't worry. So when Grace announced that this is going to be an internal, like Python kernel, how things will work, we day to day we use import, right? Every program that you write, we have an import. So just wanted to find out what is really happening. So what is really happening? You really try import foo from spam. What exactly is going on here? So how many people really know a tweaked import system really work here? Anybody has really gone inside? Okay, good. So correct me if I'm wrong somewhere. Like this has been learned for the last couple of months. I think what is there in Python and all. So obviously whatever that I've learned, I would like to share here. Okay, so this is, you can see that on the screen here. Okay, a bit of history. Python 2.5 or maybe even Python 2.7, we have the import is using a C module, imp module, which is implemented in C. I think it is completely nobody can really go back and look at it. You can really go back and look at it if you're really hardcore C programmer and trying to find out and tweak it. But from 3.3, the import lib, which is the default implementation of import. Okay. And again, this import is like completely pure implemented pure in Python. Now probably you have this system, complete system is exposed as such. You can really go back and you can put your custom hooks inside if you really want it. So you can even clearly understand what are the different. If you really go back and read the Python code, it is there in the pure Python. You can understand what exactly is going on. So Bert Cannon is one of the core developers of this. I think there is even the references. There is a video. If you're really interested, you can really go back and look at that. I think it's a very, it goes into very minute details of how it really works. It's a, full presentation is nothing but a complete workflow of how it really works from the top. So it's really good. If you're really interested, you can go back and look at it. Conceptually, what we're really talking about, there is no difference between Python 2.5 and till Python 3.3. I think the conceptually everything is same. There is no major change. But I think that the details that we are talking about are specific to the pure Python implementation. Okay, it has been exposed. The whole system is first level is exposed with metapath hooks, sys metapath. Okay, and then also there is a concept if you have heard of namespace packages. So this is a new in 3, and then we will just touch upon a little bit of what is that how it really going to work. Just a bit of terminology before going to the details of it. We have only one module. The object is module. That's all. There is no other objects are there. Even we look at everything is implemented as a packages. Package is nothing but a module. At the end of the day, but packages generally it is a way of organizing our modules. If we really compare, it is like a directory structure that we really do it. But it is not that there are different type of importers are there. So it's not just the directory structures, but you can import from different places, but directory structure is just an analogy. Okay, so if you look at, there is only one module object in Python, and then packages are also a module object. The difference between a package and a module or object, if you look at it, the package object will have a dunder path with that. If you really go back and look at, package will have a dunder path where it is originated, but the remaining is same between module and the object is same. There are certain other objects like a finder. Finder is something which is going to go and find a module. So these modules can be anywhere in our file system, like at different places, right? We can go back and this finder is going to go and find a module, and loader is the one which is responsible to load the module into the into your namespace. And metapath finder is the hook where there are default implementations of libraries. Finders comes with that, but you can go back and implement your own finder if you really want it. But basically, you get a finder from the metapath finder list. Path entry finder is nothing but you have a sys path. Basically, when you really go back and start your Python interpreter, you get all the paths which are there where you can really go back and look at it. Path entry finder is the one which will really go back and find the details for you. So simple going back in the directory. I have a directory here. It's simple. I have just to, before we really start, I have a module 1, there is one module 1 is a program or a module. I mean, this is nothing. There are 3 functions are there. Each one of them is printed. There is no major code here. Just wanted to show what is there when I import it, what really comes. And then there is a package. And then package has there are 2 other more sub packages called bar and foo. And then within that there are like some modules are there. I will go into the details. But when I really start importing a module, what exactly will happen? That's what is the next first step. So if you do from something import something there, actually it is underlying, it is just a function call which is under import. Okay, it is passing the parameters. There is a difference between import something and from something import something, But let us talk about this first from. From, if you really go back and do it, it says that from, actually in fact if you understand relative imports, dot is a relative import here. I think again this is also new in Python 3. So from a relative import bar we are a relative import bar module. So it's actually converting into a function call. The bar whatever is there is becoming here as a bar as an first argument, name of the module, and then globals and locals that can be a none, and then the list of imports that we are doing it. Maybe you can have bar module, foo module, you can have multiple things there. And the last one is the index. Index is there are 2 dots which are from the current place whatever that you are having, going back 2 levels up and then looking for that particular bar is a sub package. I have just given probably name in the back, it may be difficult to look at. I have already shown the directory structure. There is a package. Within the package you have a foo as a sub package and bar as a sub package, and then if you look at that, in the sub relative is a which is there in the part of the foo module. The sub relative is a module which is there in the foo, which is again part of the package. There is only one statement there, from dot bar import bar dot module. So means from here I am going 2 levels up, then I get the bar. From the bar I am really going back and importing the bar module. So that's what it means. It's just a conversion of it. But let's go back and see what exactly will really happen when you do all these things. So there is an import system. I'm just trying to go back to like high level flow that really happens when you do this. Okay. First thing is it will go back and check in the system like module cache. So sys.modules is all the module cache. So as soon as you say import, it will go back before do anything, checks in that whether if it is present in the cache. If it is present in the cache, it goes and returns you the object, the module object. So it will not do anything else. If it is not there, then the next step is going into the finders. The finders are all there in the sys.metapath. So you go back to each of the finder and ask the finder saying that, can you really go back and find this module for me? If it can go and find the module, it will return the module somewhere. If it's not finding the module, then it says that the module is not present in that sys metapath. Then go to the default path finders. It means you have a sys path. You go back and look at all the paths and then find out if the module is available anywhere else in the paths. If it's available there, take it. If it's not available, then I think it says that if the module is not present, I cannot really import it. If it is present, the module really comes back at this level, then what is your loader? What is the loader doing at the high level? Now, you know that there is a .py file somewhere in your like folder structure. It goes back, reads the whole file, and then it creates a code object, which is by compiling to bytecode. And the code object is there, and then it creates a module object, and then execute this code object in the scope of that module object using the exec function, and then returns the module. I mean, there are a lot many other things are happening, but this is a very high level of what is really going through when you do the import. Is that clear? So you start with module cache, look at it. If it is not there, go back to sys.metapath finders. If it is there, one of the finder can give you the object back. If it's not giving you, go back to the default path finders. Find out if in the path somewhere you can find it out. Once you have the object, read the bytecode, read the source code, convert that into the bytecode, create a module object, execute that bytecode in the scope of that module object, and then return that back to the system. Again, at this point of time, it goes back and puts it to the cache also, so that next time you try to import it again, it will not do all the stuff because it's already in the cache of that. Okay, so let us go each one of them a little bit details of it. Now we have talked about this whole how it really works from the top, from the beginning to the end. But let us explore each one of them. So okay, by the way, I think as I mentioned, the import system is exposed after 3.3 only. So if you go back on 2.7, if you try to do it, nothing will really work because the import lib is probably import lib might be there. They have started implementing it, but it is not the default one in the before 3.3. From 3.3 onwards only it is default. And again from 3.3 to 3.6 there are changes in 3.6 now. Probably at the end of the talk, if we have time, then we can talk about what are those changes. So now let me start Python and then say I have a module 1, right? So if I say import sys before import do anything, and then also sys dot module is just a dictionary. I'm just finding out whether that is there. So I don't have this, sorry, I don't have this module inside the dictionary. Okay. Now I say import this is got imported. I think now next time if I really go back and again do the import, but what was the reason? Because it's not getting executed. It's just look at the print statements, next time it is not. So what is really happening? If I again go back, look at that my sys modules, I have an object. Now this module object is stored in the dictionary. The sys.modules is a dictionary with the name module1 as the key, and then the module object is our value. So now we have got the module object. So that's why next time if you really again try to import it, it goes back, looks in the cache, and then it is there, you don't really do it. But it is a little different for packages. Let us look at what will really happen if I say import pkg dot who dot. Okay, this package I am importing from the package and then subpackage foo, and then relative is the module. But let us look at sys dot modules now. There are entries for each one of them. Package also has an entry, and then package dot foo is an entry, and then dot. So when you really give the whole, like a package, when I say package dot subpackage dot module, it's importing all of them, so that I think like it knows what is that. It decomposes each of the packages and then start importing it. So next time again, if you try to import the package is already there for you. You don't have to really go back and run all the stuff. So again, if I look at module 1, there is nothing like a path here on this one, like whereas if I really go back and look at the package, I have an element called here path, and then pkg dot and render path. If I really look at it, it's exactly the directory where it is really like imported. Oh, okay. Is it visible? Okay, good. So now we have the path element. So that is the difference between a package and the module. So now we have this sys module. Sys modules is the cache, and then you are going and looking at it there. Okay. So another important point is like the previous versions. I think there was a like a global lock when you really try to import the modules. But now from 3.3 onwards, it's at the package level. Whatever that you're really importing module, at that level only is the lock is there. So there is no, if you're importing multiple and different, particularly if it's a single thread, there is no, it's not going to make difference. But multi-thread, I think when you're importing multiple things, they're only locked at the module level. Okay, next one is on the finders. So the first step is when you import it, it goes back, looks in the cache, it's not found there, then it comes back into the sys.metapath. Sys.metapath is nothing but a list of finders. So there are 3 types of finders are there: built-in modules, frozen modules, and then default pathfinder. So if we look at the code there, it is very simple. And it is each finder, if you take it from the syspath metapath, go back, find out whether like I can use the method of my find module, give the name. If it returns a loader, return the loader back. If it is not there, then go to the next finder and see whether we can really go back and find out. let's look at it. Um, Sys.metapath, you have this one. I can go back and take any one of them. So let us take 0. Start. So it is written an object which is a frozen import with built-in importer. So it's basically sys is found in the built-in importer, it is related back here. If it is not returning from the first one, it goes back to the next one and then next one. That finders, each finder really goes through, iterate through, and then find out the module wherever it is really present. So a bit on the namespace packages. Oops. Okay. So namespace packages, if in the same directory I have another package called module 2. So if I say import module 2 dot so there is a module called span within the it says module 2 is a namespace. Anyone knows how is it different from the normal? How do it says that is a namespace package? So if you really go to the package, one of the file that is identifying this is a package is what? Render-init.py, right? If you have render-init.py, it identifies a package. But in Python 3, you don't need to have a render-init actually in fact to really import a module. That's what it is treating as a namespace package. So what happens is when you really go back and import in a directory where you have a directory and then you don't have a render-init file, it still imports it, but it really says as a namespace. I think it may be good or bad, it depends on what your use case is there. But if you really look at it, if the same module, if you are trying to import from multiple directories, the same package you are trying to import from multiple directories, actually it will combine all of them as a single package in the namespace. That's what is called as a namespace. So, but when it is there, init dot, where render-init is there, then it means that all your submodules and sub-packages and everything should be there in the directory only. But whereas for the namespace, it can be present in the different. If I go back and put this module 2 in a different path somewhere in my path, and then I put foo.bar there, both spam and then foo, both of them will become the part of the package module 2. So it's really combine all of them across different directories in the whole file system. Okay, so that is what is namespace. So this is another thing that they really look at it. They have to really figure it out whether it is a namespace package or it is a normal package, and then based on which they have to really make a decision. Yeah, these are the two. I think built-in module importer and frozen module importer is there, and then the default path finder is the one which iterates through your path. Sys.path, there are directories. You can add what are the other paths where you are really putting your packages and modules. It will go to each of the path and then give as a directory as an input to the finder and find out whether it is present in that particular path or not. So so these are the different directories inside the sys.path. But what is the difference is there are path hooks. So the path hooks is nothing but like first level is your meta path finder, when that is a meta path, okay. But after if it is not finding out, you can also go back and write your own functions which you can really go back and put into the path hooks. There is one more sys. Actually, if you look at it, the meta path finder is even before you really start doing your importing. But this is after built-in modules and after frozen modules are really completed, then you are starting with your default path finder module. In that you can go back and put your path hooks. So what it means is you can write your own function and then go back and then plug it here. It will go back and take this and then you're actually modifying the behavior of the import as such, or customizing the behavior of the import. So This takes an argument of your path actually, in fact. So if I say slash home, this returns a file finder object. So basically you have in the path hooks, you have a class which takes an argument as a path and gives you a the finder object. That finder object you can go back and find out. And then I can give for this as a, I can store this into a finder. Find module. So it gives you the finder that you can really have a you can load this module if you really want it. So this is what exactly is happening. You go to the sys path hooks, take that, give it an argument as a that takes an argument as a path and gives you a finder, and take the finder, and then you go back and get the finder object and you got it. From the finder object you'll have a loader and you can really go back and execute that. Then once you execute it, you'll get the module back with that. Okay. This is how Python the pathfinders will really work. And before even going to the path hooks and looking at it, there is another cache is called path importer, path importer cache. So what it means is, when you are trying to really go back and import these modules at multiple points of time, it goes back and searches the directories. When it searches a directory once, it will go back and make entry into this path importer cache. If already this directory is looked up earlier and if you found something or you not found something, it goes and makes an entry there saying that I have these modules available here, I don't have a module available there. Then it's not going to go back and look it again. So before even it goes back and look at the path, it goes back into path importer cache, looks there whether I have already looked at this directory. If it's already looked at the directory, then it will not really go back and look at again before even going. I mean, this is all a reason for performance that is required. Because the earlier one was in C, I think it's much faster. Now we are implementing everything in Python. You need to ensure that it is performance. So there are a lot of cache that is available for you, so that you don't really have to go back and look at every time you're doing these operations. So what is the loader? Finder will find a loader. Once you have the loader, I think I have mentioned the steps. Now loader will really create a module object, go back and read the code, put that execute that code in the scope of that module, and then give that back. So there's another one. If you really look at it, earlier even there were PYC files used to create in our directory whenever you do it. So what is a PYC file? Bytecode, right? So what else is there in the bytecode apart from that? When your file changes, how does it know that this bytecode is invalid or valid? Is there any way of finding out? Sorry? Yeah, there are certain attributes. So before it generates, I think this is also part of importing the module now. So what it will do is, it will go back and look, before even trying to go back and do all the stuff, it will go back and look in the directory whether there is a .pyc file. But .pyc file was there in the same directory where you were really importing the module earlier before 3. But in 3 and all, what is there? There is a render pycache. There is a directory called pycache that gets created. And then even if you are working with multiple versions of the different libraries of Python, it really go back and put into that particular directory. So you go back and look at it. If it is there, it will go back and directly bring it back. It will not go back and do all the compile, execute and everything. It will just go back and take this file, read it back, and then it's just already a bytecode. So marshal that object and then give it back to you as a module object. So let us talk about a little bit on the module spec. So this is another a class which is there, but I think in 3.6 they are trying to change the way that is there. There is a find module and load module. There are two of them, which they are trying to deprecate, and then they are asking you to do a different process. What it means is, you go back and find a module spec rather than finding a like a find module give you a module object, rather than you go back and find the spec. Let's look at it from okay. Import read or util. So this is a module spec object. So if we just go back and say the find spec, it just gives you a specification of the particular module. What is the name of it? What is the loader that it is there, and then where it is really originating from. So you take this object and you can really start working with this object. You create a module out of this, and then you can load that module. So module spec is basically rather than taking the whole module as such, you're just finding the specifications of the module. Okay, so finally, if you look at the simple implementation of this, like a module, how to create the module object. This is not exact, but this is a simple implementation of that. Read the code. If you look at the the code here, you take the module name as an argument for the import module. You go back, append that .py, because wherever the source path, the module name .py is there. Open that file, and then read all the code into source code. Create a module object. It is as simple as module equals to types.module type module name. You give it. It's a module object has been created, and then you go back and there are lot many other attributes that you are going to set it on the module object, but one of them is a .5, which is the source path where it is originated from, and then compile. Compile is a default function in Python where it takes is the source code, and then source path, and then it really gives you a bytecode using the it is really created for exec function. So the code object you really execute it in the scope of mod.dig. So this is what you will return, that the module whatever that is created, that you are really returning back, and then you are going to go and put this module into the sys.modules as a cache. So that's the end of the import process. So you found the loader, module. You created a module object, and put it into the sys modules, and then give it back. Any questions so far? Okay. So what is difference between 3.3 and then 3.6? So you find a module spec rather than actually in the 3.3 versions of it, you are finding a module, find module, and then you are using find module and load module. But here we are really going to use the modules find module spec. Once you have the find module spec, you create a module object, add the module object to the sys.modules. Actually, you are doing this even before you really create the module object. Is there any reason why are we doing this? If you look at the third step here, you are adding a module to the sys.modules before you really go back and create the module object and then return the module object. Even before you start doing anything, you are adding this to the sys.modules. So this circular imports, right? You can really go and then say import foo from bar, and then other is a import bar from foo. There is somewhere you should really end this. So this is what is really going to end it. What it really do is, if it's already there in the cache, then it will not really go back and look at for all of them. So it really stops there. So to avoid circular imports, you start with this. But if there is any error, they are going to delete from the sys.modules cache. So then execute the module, return the module object. These are the all the steps. And actually the code is here. If you really look at it, maybe I'll just quickly go through this one. So module, you are really just creating a module object first, module this one, and then if the spec.loader is not none, and then attribute that spec, whatever the spec that you're really having is loader and create modules are there, I'll just create a module object. These are all, the spec is the module spec that I really talked about. It is having a loader. On top of it, you create a module by supplying the spec. If you give the specs to this create module, and then it will go and create the module. Sometimes even after creating it, module can really be a none. So if it is none, then you say that you go back and create a bare minimum module, which is going to be from the direct module type, which is the part of types system. Okay, and then this is where I added in the previous code one of the file path as an attribute, but there are a lot of other attributes that you are going to initiate for this particular module. Path, like I think if it is a package, you have to, if it is a sub package, you have to go back and say what is the parent path and all, parent path and all those things. And then if this is none, the spec loader is none, the spec module search locations is not none. Basically, the spec has even submodule search locations. So if they have like other locations that submodules you have to really search it, there will be a path. You go back and look at it. If that is already presented, I mean, if the sys.module module spec name is equal to module, if it is not none, else you just go back and like raise an import error. So I mean, at the end of the day, you are just taking the spec, and then these are all different things that you are really checking for it. But module is created from the loader of the spec using the create module, and then using the load module, we are loading the module. So it creates a module object that you are going to set it in this and then leave it. That's all. So this is where I think if there is any error, if you are trying to load execute module, this is where you are really executing the module. If there is any error that at this point of time you are going back and removing from the sys.modules. Okay, so let me also do a little bit on this. I have in the directory the same wherever I have this. Oops, give me a sec. So I have a mypackage.zip. So there is a zip importer basically. So what it means is even if you have a module which is not required to be in the directory structure, but there is a zip, the zip importer will really try to get this object. So sys.path hooks, right? This is first one is the zip importer. If I really say so my importer object is there. So basically what it means is even if you have a zip files, it need not to be exactly the directory structure, but if there is zip files are there, it can go back and import that and then try to work with the zip files also. Oops, I think there is a problem with this. So what I cannot do, I mean there are metapath hooks and there are syspath hooks, but some of them you cannot really do. Modify the startup. You cannot really modify when you start the Python interpreter, one of the main program, you cannot really modify the main program behavior. It's after you really start it, you can really go back and modify the import behavior, but not the main behavior. You cannot change the language features. The language features, whatever is there, you cannot change with the import, whatever that like libraries that you have really looked at import clip. You cannot really go back and change it. But what can you do? So let's say one of the example, like I'm just now, let's take I mean this may not be really, like realistic example, but just I'm taking in, like a kind of use case. Let's say you're using, like Amazon, and you really have all your modules, like really kept in an S3 bucket in an Amazon. Like S3 bucket is nothing but a storage in Amazon. Okay, probably I can go back and add. I can write my own finder to really go back and put it to the metapart finder and then say, rather looking at all the default, like your directory structures, you can go back to Amazon, look at the S3 bucket, find out if there are modules available there, bring the module back into my thing. It means that you can connect basically to remote machines. Not only remote machines when I say, it could be either cloud or it could be even a remote machine, something is available somewhere. As long as your finder can go back and find that particular module and can read that, like a Python file and everything. So that is one kind of use case. And second thing is, some people really want to link what's really happening, what people are importing in their organization. Like you think you can go back and log in to your import, so that somebody really try to import something, it will go back and put a log saying that who has really imported what kind of modules. So remote source logging, virtual import paths, again, fixed circular imports. If there is something that you can always go back and modify the behavior to really, fix the circular imports. Another use case is lazy imports. So, actually now I think 3.6 this is part of default feature of the Python itself. I don't think we want to write it, but the previous way, people can go back and write the lazy import. What is a lazy import? You go back and do an import, but nothing is really happened at that point of time. But somebody tried to access an attribute or try to execute a method of that particular module, then you go back and import at that point of time. Till then you don't really do anything. So that's another lazy import. Post import hooks. I think you can really say after importing, if you want to do something, you can go back and implement the post import hooks. And custom module types. I think you have seen the module type, right? I think they can really go back and inherit the module type from the types, and they can create your own module type, which can be completely different. You can create your own custom module types also. So these are the typical, these are you can do it, but it is not that you need to really do it. If there is a real use case for you, you can go back and look at it. So there are some references here. Python, primarily the Python documentation, even though it's not 100% clear at this point of time, but there are a lot of information is available. And then Brett Cannon, there is a how import works. He has given a talk. I think this is really a good one from with the default with all of the complete workflow. He gives it. David Beasley talks about modules and packages in one of the PyCon, but this is again 1 hour or maybe 3 hours video. But I think it may not be relevant for all import, but there are some imports I think it really hacks into different things. I think it's really good. If you're a hacker, you can really go back and find out what exactly is happening behind these things. And there is another small video getting the most out of Python import. This is also gives you a very high level of it. So before I go further, I have one. So this is a simple example of how we can really create. So this is a script where it says that import lib ABC. This is abstract classes are there. I think you can read off, go back and really extend all your things from the import lib ABC. All of the abstract classes are there here, and I'm just giving a simple logging importer, which is a subclass of the finder, and then in the previous one we have to define the find module, which is the like class method. Then we go back and define the find module, which takes as a self as well as name and path. And then I'm just printing it if it is there. So if I go back and add these two, let us take this piece. So now actually I imported since the logging importer, I have really inserted into the meta path finder. If I say, see, I just put it, I'm importing math, which is the module. It says I'm importing math by logging importer. So it's really going through, it is executing this code because again I'm putting into the beginning of the list. So it goes first into this one and go to the remaining things. So it's just printing this logging message and then going and importing the remaining things. I think that's all I have unless you have any other questions.
How do you resolve circular imports? Circular dependency, right? Not dependency. Circular
Imports.
Yeah. So sometimes it gives an error like the app crashes or something like that. So how do you resolve this thing? How do you find out the exact cause, like the root where it is happening? And how do you resolve this thing?
You are trying to say that how do you debug and find out where exactly this is really happening and
Okay.
where it is really going on?
Yeah.
I'm not sure about the simplest or easy way to really do it, but not really go back and do it. But one of the features that I really mentioned is trigger the sys modules. You are caching it much before you are really doing anything is to really avoid the circular imports. It means if still we can really able to really go back and get the circular imports, I think we want to go back and find out where it's really happening. But I don't know exactly how we really go back and debug it in a complicated environment. It is a simple thing that that exactly you are doing it from 2 modules. But if you are having a multi-module, this one that is really doing it, I'm not sure. But what you can really do it is probably now you can go back and put your import hooks. Like I think if it's something is been already imported and then you are really trying to import multiple times. For example, say the count of that particular module, you are really increasing it, wherever. that you can go back and then put into one of the metapath finder, write your custom code. If you try to do the same thing again, if I try to import the same thing in another places, then you can really go back and fix something. But you can try, but I'm not 100% sure that, but you can really go back and do that customization in the metapath piece, probably. That might work.
I think we are done. Maybe you can reserve the question for the at the end of the